Welcome back to Cloud 42, I'm James. Today we're going to build a set of soft jaws for my mill vise. This is my mill. This is a Grizzly G0704, at least it began life as a Grizzly G0704. This is a CNC conversion. I've got stepper motors on the front and I've replaced with 3 ball screws, and it's all computer controlled using Mach 3. This is actually a Haas conversion. Maybe we'll take a look at that in a future video. We are still working on the toolpost grinder, but there's some parts coming up like the motor clamp that don't have any parallel sides, and so they're hard to hold in the vise. Let me move the camera over here and let me show you what we're going to build. This is my mill vise. This is a Schar's 440V. Excellent vise. I've really enjoyed it. The jaws that come with it are steel and they are hardened. There's several marks here where I've hit it with high-speed steel end mills and they didn't even touch it. The one place where I scratched the jaw was carbide. These are incredibly hard, and they work really well if you're going to clamp something rectangular into it. You know, any kind of work that's rectangular in shape, you know, a piece of cold rolled steel, we drop it in there, clamp it down, works great. But what if you need to clamp something that is not so regular and doesn't have parallel sides? This is an extreme example. But you know, if I was trying to mill this out, there's no good way to hang on to this. Say I was trying to engrave this and put text into it. There's no good way to hang on to it. There's lots of ways you could do this. You could put a mini pallet in here with clamps and some kind of hold down to hold things in place with shims and try to level the thing out. Or you could use soft jaws. The idea with soft jaws is that you replace the hardened steel jaws with jaws made out of soft steel or aluminum that can be milled, and then you mill out a pocket in the top of the jaws the shape of the part you want to clamp. So if I milled out the shape of half of this wrench in the back jaw and the other half in the front jaw, then I could set this down into that recess and clamp with the other jaw. So I don't have a set of soft jaws for this vise, so that's what we're going to make today. You can, of course, buy them. I have the material the right size, so we're going to go ahead and mill them. Now the finished length of the jaw is going to be 5 inches, so we're going to want to cut the stock a little bit longer, 5 1/8, maybe just a touch over that. And since I've got several to cut, I'm going to set a stop. I'm just going to set this to 5 1/8 or thereabouts. It's just over 5 1/8. Now this is 1 inch by 2 inch extruded 6061 aluminum, and this is actually a little bit taller than the stock vise jaws, but that will allow us to mill these jaws down multiple times after using them. Okay, let's do one more check. Measure twice, cut once. Yep, and that is just over 5 inches. Okay, here we go. Okay, that's one. I'm going to check the length here. Make sure we're square enough. We are. And I have always wondered, when I'm cutting a 1x2 piece like this, am I better off cutting it vertically or horizontally? Which cuts faster? And since I have to cut 2, I'll do one each way, and then I'll check the video and see how long they took. Just up against the same stop. Nice and tight, and one more cut. You can see the saw bouncing just a little bit, and the reason for that is there are 3 or 4 teeth missing off of this blade. It was a brand new Starrett bimetal blade, which is fabulous, by the way. variable tooth pitch so it doesn't set up harmonics and it cuts smoothly. But I had something that wasn't clamped securely and it pulled out of the vise and jammed and tore 3 or 4 teeth off of this blade. So that's no fun, but it still cuts okay. So okay, that wasn't nice. Jammed and popped off the wheel. I'll have to reseat the blade. We're over here on the mill, and the first thing I need to do is set the 0, and I'm going to set it at the bottom of the left front edge of this vise jaw. And the reason I'm going to do that is because we're going to have several setups here, and I've got all of them referenced off of that same point. That way we can just swap the stock in and out, and it'll stay the same for all the setups, and we don't have to move things around. Let's spin this up, about 1,000 RPM. There's the edge. And there it is. And there it is, just gripped it. Now I'm just going to go ahead and put the workpiece in the vise. This stuff is pretty parallel. It's certainly not perfect, but it's close enough. Especially since we're going to be facing down all the sides and cleaning it up as we go. Okay. Now the first tool we're going to use is this face mill. This is a 2-inch carbide face mill, or rather it's more like 50 millimeters, which is 1.9 inches. And I think for this cut, we're going to get a little coolant going, just to make sure we don't get chip buildup. We've got the tiniest little ridge on the back there where the face mill didn't quite clean it up, but other than that, that is just gorgeous. Okay, for the next setup, I need to continue squaring this block. So I'm going to take out the parallels, and I'm going to turn this part so that the part that we just milled flat is back against the vise, against the fixed jaw of the vise. And then we'll mill the top off and it'll be square to the back. Make sure I don't have any chips in there. Now in this cut, whether it's bottomed or not doesn't matter that much because we're going to establish a side that is at right angles to the back. Okay, and that's the second one. Okay, next cut is going to be to face the other side. So I'm putting the side we just faced, so I've got two right angles here, one side and one edge, and we're going to put the side against the fixed jaw and the edge down. And this time it matters that we don't get any chips because we're trying to face this second side parallel to the first. So we will also tap that down with a mallet. Okay. Now I want to take another 25 thousandths off of this side. Okay, that looks good. The tool leaves such a beautiful finish. Okay, so now the final setup for these to do the fourth side and the ends. To make sure everything is clean. No chips at all. Parallels are coming back. Make sure the parallels are clean. And so now we've got three sides, two that are parallel and one perpendicular. We'll just put that down. Now, since we're going to be working both ends of this, and we're actually zeroed off of the vise jaw, I need to make sure this thing is completely centered. So we're just under 5/8 out that side. I got a neighbor playing with his car. Okay. 9/16, 9/16. Okay, let me snug this and then get a mallet and make sure it's really seated. Check the parallels. Parallels are tight. I think we're good to go. Okay, there's three tools that are going to operate on this. The first one is the same thing as before. We're going to face it off. And then we'll come back with an aluminum specific end mill and cut out the holes and trim it to length. Okay, time for a tool change. Before we actually put the next tool in though, I'm going to take care of that tiny little burr that gets raised on the back, just to make sure it doesn't become a problem. Technically it's not a burr, it's a place where the end mill missed. I told the software it was 2 inches and it's really 50 millimeters. Okay, that's clean enough. Okay, the next tool that's going in there is a 3-flute aluminum specific end mill, 3/8 of an inch. Now this is the first time I've ever run this particular tool on this mill, so we're going to give it a shot. I've run the 1/4 inch ones. They work great. This is the 3/8. It'll take a little bit heavier cut, and we'll see how this goes. I'm also trying some boring and some plunging operations that I've never done before. Biggest thing about a larger end mill like this with a high degree on the flutes is they can try to screw into the work and pull themselves out of the spindle. So I'm going to snug this down nice and tight with the drawbar. I have had that happen, and you can probably see the marks on the top of my vise jaws. Tool lost, the hardened vise jaws won. Okay, like I said, this is the first time I've ever run this tool. Let's see what it does. Make sure we got lots of air for chip evacuation. And just a little bit of fluid. Well, it was a little bit noisy going down and doing the inside of these holes. And I think that was just trouble with chip evacuation, but it held up and it looks like it turned out okay. Okay, the last step will be to get a chamfer mill. See how these feel. And it still feels sharp. So the next step will be to get a chamfer mill in here to chamfer around that hole. Okay, so technically this isn't a chamfer mill, this is just a spotting drill, a 90-degree spotting drill. But chamfer mills are very expensive and these are pretty cheap and they do a nice job. Okay, that's all the machining operations. Looks good. It's all complete except the deburring. We'll do that over on the bench. Okay, the first thing I'm going to do is deburr these holes. And it looks like there's a tiny piece of aluminum that didn't get punched through. Probably didn't get that op quite deep enough. Just deburr those, little Noga rotary deburr. Now all the edges I want to clean up with a file. These end ones haven't been done yet. The back ones have. Do these top ones here. All the top faces. Now this is that edge that didn't quite get caught by the face mill, so it's going to take a little bit of extra work. Okay, that feels nice and soft. I don't want to take too much off of these because I'm counting on the faces of these to be parallel. Okay, that's that. Okay, well, we've got vise jaws to go in the vise. Let's install them and see how they fit. Like most jaws, this is a 4-inch vise, and I went ahead and made these jaws 5 inches long so that they're extension jaws to hang on to slightly larger parts. And so these, like most vices, have 3/8-inch bolts in them. I need to get a driver for my impact gun so I can just spin these out really fast. Okay, harden jaw out. And that's the second one. Let me get a rag and wipe this out. And this will actually be the first time I've tried these in this vise. I just designed these and drew them up based on the diagrams on the manufacturer's website. Hey, I think they're going to fit. Okay, I think that's that. I'm gonna give them a little tap and make sure they're down. Yeah, they didn't move at all. Let's try the other one. Make sure we're clean. Must have a chip in the threads. Yep. Oh yeah, that's much better. Now I'm just going to center these up on the screws the best I can. Hopefully they'll come together when we close the vise, but if they don't perfectly, it's not a big deal. It's just because there's a little bit of play in the screws. Because the holes are slightly larger than the screw diameter. Yep, it's down. And there we go. Those close up beautifully, and the top is just about as level as I can feel. Ultimately, it doesn't matter, because if we were gonna, let's say we were gonna make this, or gonna engrave this wrench and needed to hold it, again, what we would do is open this up and clamp it on something to hold it open slightly. Maybe a parallel. Clamp this closed or slightly open, and then we would CNC mill the shape of the part we wanted to hold into the top of it. Then you can just take the parallel out, drop this into that, and close it. So it doesn't matter that the top is perfectly parallel. They do happen to be very, very close, within a thou or two, because you're going to mount these on the vise and then mill into them in order to hold the part. So it'll actually be the bottom of that milling, which will match up to whatever the coordinate system is on the mill. That's it for today. If you like what you're seeing, please give me a thumbs up, and be sure to subscribe so that you'll be notified of future videos. And also that bell next to the subscribe button turns on notifications so that you'll be notified immediately when the new videos go up. Thank you for watching.